Volume. As we begin to discuss volume, we'll be using unit cubes to help us find its measure. They can represent a variety of measurement units. Examples include cubic centimeters, cubic inches, or cubic feet. Let's see how unit cubes can assist us in determining the volume of a solid. Let's start off with an example. Morgan is helping his younger sister put away her alphabet blocks by placing them in a box. She has already put away one layer of blocks. It takes 15 blocks to make one layer. If the box is filled with 4 layers of blocks without any gaps, how many blocks will be in the box? To start solving this problem, let's examine what we have given to us in the word problem. She's already put away one layer of blocks. Well, the question is, how many blocks are in that layer? Well, it takes 15 of them to make one layer. Okay, think about how 15 blocks can be laid out. 15 only contains 2 other factors besides 1 in itself, and that's 3 and 5. So it could be composed of a rectangle that is 3 blocks by 5 blocks. So let's start there. Use the unit cubes to model a layer that is 3 blocks by 5 blocks. So that's 1 by 5. These will be, this is the second layer of 5. Okay, so now we have 2 layers of 5. And now we can do it again to make the third layer. Okay, so here's our 15 blocks that we have in one layer. Now let's go to the next step. So we took care of one layer, and we know that it has 15 blocks to make that layer, so those are done. If the box is filled with 4 layers, so could we take the layers that we have here, this is just 1, can we make 4 of these? Absolutely we can. So that's going to be the next step, to make 4 layers of these exact blocks that we have. So let's start making our next layer. So here's our second layer of 5 by 3. So we have one layer of 15 and another layer of 15. Let's keep going. Here's our third layer of 15 blocks. Now let's do our last layer. And here's what it looks like with 4 layers. So we have 5 by 3 by 4. So we have 15 in the first, 30 in the second, 45 through 3 layers, and then 60 through all 4 layers. So this means that we have 60 cubes. So how many total blocks did we use to make this model? There were a total of 60. And here's what we worked through. And it shows our 60 blocks or 60 cubes that were used. The total number of blocks that were used represents the volume of a box. This box is called a 3-dimensional or 3D figure, or a 3-dimensional or 3D solid. A 3D solid has a length, width, and height. Here's an example of what's known as a rectangular prism or a block, and it has a length, a width, and a height. The 3D figure also has what's known as the base, And by base, what we're really talking about is the bottom of the figure. And this base ends up being a rectangle. So the volume is the amount of space occupied by or inside of a three-dimensional figure. Volume is also the number of cubic units needed to fill a three-dimensional figure. Layering is an example. The unit of measurement for labeling final answers involving volume are units to the third power or cubic units. Why is this true? Well, if the length was, say, measured in centimeters, and the width was measured in centimeters, and the height was measured in centimeters, to find the volume of this solid, we would multiply the area of the base, length times width, so centimeters times centimeters, and then you're going to multiply that by the height, which is centimeters again. And when you multiply centimeters times itself 3 times, that's centimeters cubed, or cubic centimeters. And it holds true for any solid that you are finding the volume of. You will always have that unit of measurement be to the third power, or cubic units of measurement in the end. A 3D object can also be decomposed or broken down into rectangular prisms or unit cubes to find the volume of the whole object. So for example, this figure could be broken down into 2 separate rectangular prisms, or they could be decomposed. The first one has a volume of 3 cubic centimeters, and the second one has a volume of 2 cubic centimeters. So if we add 3 and 2 together, we get a total volume of 5 cubic centimeters. Look at the model of each prism. Fill in the table in order to find the volume of each. So let's start with this top one. We have the length here, so let's count it 1, 2, 3, 4, 5. 5. Its width is back here along the side, and there are 1, 2, 3 blocks wide. And then the height is 1, 2, 3, 4, 5. So if we were to actually examine this and try to picture what we're doing in order to find the total volume, we would have a 3 by 5 rectangle on the bottom, and a 3 by 5 rectangle has an area of 15 square units in one layer, and then a second layer of 15, a third layer of 15, a fourth layer of 15, and a fifth layer of 15. So if we take the area of our base, which is 15 square units, and we multiply it by our height, which is 5 units, it will give us the total volume. And 15 times 5 is 75 cubic units. Now let's look at this other rectangular prism that we have. Its length is 4. Its width is just 1. And then its height is 3. So this first layer down below has an area of 4 times 1, or 4 square units. The second layer also has an area of 4 square units, and so does the third. So if we multiply these areas of 4 square units by the number of layers, which is 3, which represents the height, we would end up getting a total volume of 4 times 1, which is 4, times 3, which is 12 cubic units.